Morning, everyone. You had a good weekend. The exam results are in. There were some very good results, quite a few hundreds actually. It was a little surprising but if you studied, there was that opportunity to do well. To the other extreme, and as I'm updating homeworks, one of the things I want to reiterate is yes, you have the ability to self-pace yourself throughout the session, but don't wait till the last day. Don't wait till the last weekend after the test. You have to the homework's there to help you prepare for the test. Some people were saying, is the homework harder than the test? How many of you felt the homework was actually harder than the test questions? Hopefully, you know. Test questions were hard because you couldn't have resources, right? And you're under stress and time and all that kind of stuff. But the goal is that the homework we have you do, if you work through it, yes, it will be a little bit harder, but it'll prepare you for uh, to make the exam when you come in that, hey, you can do it. Um, Now remember, this class does not do a comprehensive final, so exam one stuff is for the most part done. We may make reference to it, but we're not going to pull up and have you do a Lagrange multiplier again. That's done. Okay, so we're going to get into the new stuff. I did extend the homeworks until Sunday night. There was a few requests to go a little bit further, and I just said, no, we've got to start on the next stuff. Um, and the same thing will happen with this stuff is it'll be due the day of the test, and it's best to have it done by then. Will I probably extend it over the weekend? Yeah, I probably will. But it's to finish up a few things, not to start on the whole set of homework or to leave a bunch. So just keep yourself going, because that's one of the best lessons you learn is from your mistakes. So if you didn't do as well as you want, look back at how you can improve. Uh, One thing that's still left to do is it's still open, the exam one review. I set it up as a quiz. There's one right answer that yes, I did this stuff. I did the review. The other ones are no, I didn't do the review. You'll only get points if you say you did do the review. Okay, you don't have to upload anything. You just have to say yes, you did the review, and hopefully you're being honest. That's what I expect of everybody. You didn't do it. Those few points aren't going to make a big deal anyway. So 10%, it's about 3.3% of your total grade, that quiz grade, right? Um, if you don't do well enough on the exams, it's not going to matter anyway. So, but do enough of the reviews. Now, I'll just be clear. A few people contacted me. The questions are and or questions. So there's three things I asked if you had done them. If you did one of them, which was just review the questions, it doesn't even say do the questions, but you at least reviewed the questions, looked at it, then you could say yes. Okay, so just want to be clear. That's what's there. And it's the reason I did this is it's also self-grading. So if you answer the right way, the points go in, and I don't have to go back and do anything. Okay, so if you haven't done that, it's there for you. If you've done it, great. Uh, so just click on that. They'll open up like a quiz, and again, you know what the answer is. So, any other questions about exam one stuff or course? Okay, good. So then let's get into, we're starting in learning activities for exam two content. So I'll point this out right now. There's actually the exam two review resources, which has the course coordinator prepared review. I haven't highlighted anything yet, but it's there. You might want to start taking a look at that as you go through the homework. You say, okay, this section, can I do the test? So pace yourself. So you're not doing everything the last week. We will still have the 2 days for review, but that could be helpful to just kind of make sure you're hitting on the cylinders that they're going to want. Because again, these are the questions made up by the course coordinators. They will be reflective of what will be on the test. I've got our first section in here, and I'll keep going as we go. I've got our class schedule, so let's take a look at that. Actually, I think I have it down here too. So it's just a PDF. One thing I wanted, Friday, I had appointment I couldn't get out of at 8 in the morning. It's only like a half hour, but I can't get to that appointment, go through it, and get back here. I can get back here by about 9. What I'm going to do is there was a few that had valid reasons for missing the exam, illness and family issues. So I'm going to do a makeup exam 9 o'clock, uh, not a retake exam, just a makeup for those who contacted me. So Friday is your day. Okay. So we'll do two things on matrix, and I'm going to show you a few things in the graphing calculator. So today we're just kind of doing introduction to matrices. And then we'll do some operations with matrices, and then you'll have kind of Friday to get through the homework, play with it so that we're ready to go, because uh, it gets a little complicated when we're dealing with matrices. This one, though, again, I will show you the technology. So it's very important to have, well, if you have the TI-84, that's kind of what I'll be demonstrating because that's what most of you have. But there's some other ones out there that are great at working with matrices and that will do all this kind of stuff. And I'm going to show you it's kind of a good memory tool because remember, I'm dyslexic. One of my problems with matrices is I do a lot of transposing. And so I mix up rows and columns and stuff. Calculator will help with that. Okay. But we've got a good pace. We'll get into some counting methods. So basically matrices, and then the second half of stuff is probability, which is really just counting and dividing by the total. So you count how many you want. So probability is actually a fairly good thing. And it deals with percentages. It also was my major when I was working on my master's degree. So it's got a lot of business applications. So that's where we're going. And then we'll take an exam again. We've got a full 2 days of review. I'm going to have to get since we've got spring break, I can get a little bit ahead. My plan is to make up a worksheet that's like more of a practice test. Same type of stuff that they've got, but maybe some of the practice problems. Give you all a little bit extra. Okay, so let's go in. Okay, there we go. Okay, today we're going to just look at matrices as a mathematical structure. Okay, we're just going to look at the structure, not so much about what we could use it for, because matrices can actually get used for various things. We can use them thinking of them as the coefficients on equations. Okay, so we'll do that, and that helps us solve for variables. You can also, there's a couple examples in there where you've got some data, so you could use them like that, basically like a spreadsheet. So a matrix is a mathematical structure. They have rows and columns. And again, this is where I start to have some trouble sometimes. So catch me quickly if I get them mixed up, because it's very likely I will. It goes by rows and columns. So M is going to be your rows, N is going to be your columns. Okay, so what a matrix looks like is they'll usually use big old brackets. And so a 3x4 is going to have 3 rows and 4 columns. So there'll be entries like this. Okay. And again, we're just looking at it as a structure. What the stuff inside there will be numbers. There could be some letters, but primarily we use the matrix for having numbers in there, and then we do a lot of things with them. But that's what a matrix is, and the dimensions of the matrix are how many rows and how many columns it has. Okay. You can see we could get very large ones, and that's definitely where you want some technology to help you through those, because it's very messy. Each one of these individually These little spaces here, those are called entries. So in a 4x4, you're going to have 12 entries, right? So it's a way of organizing a table, much like a Excel spreadsheet, right? So we've got that going for us. And then we usually name the matrix with letters. So we might call this, say, okay, this is matrix A or B or C, and we'll do that. And we'll show you the calculator follows these same um, uh, rules. So here's a few quick examples. So here's a matrix A. How would I list the dimensions of this? Is this a 2x3 or is it a 3x2? It's a 2x3. Rows first, columns second. So it's a 2x3, right? 2 here, 3 there. Good. 2 rows, 3 columns. And that's just something you're going to have to practice with. I know you say, oh, that's simple. I'll remember it. I don't. And I've dealt with them many times. And I remember it, but using it, because sometimes our brain just is used to doing things differently. And by the end of the lesson, we're going to do something called a transpose where we're switching them anyway. That's where I get lost is, oh, wait, transpose. Actually, I'm pretty good at transposing because that's what I do naturally. How about this one? 2x4 or 4x2? 4x2. Rows first. Good. So this one we're going to call a 4x2. So see, so far not so hard. It's just, but it's also we have to get these things down. So we're getting foundation today. Uh, Nothing we're going to do is difficult, but it might be different than what we would have done or how we think of things. It's how somebody else said, I'm going to make this system and this is how it's going to work. I know when I do that, like my templates, even when I used it the second time, I didn't like my templates, some of my templates that I did. So anyway, and then you can list each of the entries. So each individual item is an entry. And I'll just, I'll get a little bit ahead of the slide. Let's say this number, -22. We could say that is an entry, and we label it by its row and its column. So this would be A22. So entry, oh, that's kind of interesting. Entry 22, its answer is -22. I just didn't even know that. Maybe sometimes our brains think faster than we can think, but maybe I spotted that. Anyway, does that make sense? So we can label each one if just so that you know what I'm talking about. So if I were to say, I want to talk about entry 1, 2, which number am I talking about? What value? 1, 2, it would be this number here. There's 2 zeros, so you don't know which one I'm talking about necessarily, but you know that the entry in that field, 1/2, is 0. Okay, makes sense? So a lot of this you just got to be able to follow along. And if you just remember row, column, row, column. If you like RC Cola, there you go. Just remember RC Cola, row, column. Do they still have RC Cola? You guys even know what RC Cola is? Dang, kids, that was like more popular than Coke because it was different. RC Cola. Yeah, I think they went out of business. Okay, here's another one. So this is the one that we just sort of did. So first row, third column. How would I write that? I would write that as A what? 1, 3, right? Sometimes you don't have to answer, but I just want you to think that pause and time. I studied some foreign language, Thai language, because my wife is Thai, and there's this system where they give you a word, they give you the translation, but then when they give you the English word, they pause because you're supposed to fill that in. And that is an amazing way of learning. So what item is in the first row and third column? First row, third column, 1. And exactly. And sometimes they use, I don't know, they could use a little letter A or a big letter. So take either. Okay. How about second row, first column? Second row, first column. And we could list that either as little a or big A. and that would be 2, 1. We'd say that's 33. Okay, makes sense? And your homework, that's some of the first few questions, that's what your homework's going to have. They'll give you a matrix and they'll ask you, what's the entry in that field? They'll give you a matrix, ask you what's its dimensions. Go through and do them. Okay, they should be quick, and uh, there are no word problems in the homework, at least none that I saw. Sometimes I miss things, but I don't think it's all pretty much just do it, right? It's all set up for you. So here's a little thing that, the labeling convention. So I guess they're using little letters for the entries, big letters for the matrix. But again, you could use really either ones, because as long as you have these little letters down here, it's kind of indicating that that was row 1, column 3. Okay, so, and again, as the matrix gets bigger, we just change those little indices that tell us which entry they're talking about. Any questions so far? Okay. Okay, let's talk about when are two matrices equal. What would make sense for two matrices to be equal? Would it make sense that they'd have to be the same size? Because equal means the same, right? So a 3 by 4 really couldn't be equal to a 4 by 3, right? Because they're not the same shape. Or 1 by 2 couldn't be equal to a 5 by 6, right? So one of the things is they got to be the same shape, first of all. And then to be equal, if they're the same shape, wouldn't it make sense that each of the entries are the same? That's all it is. Okay, so sometimes, but what I want to point out is that was sort of a hard thing to me. It says it seems so obvious. Why do they even have to state it? And so I want to bring it out. And so this matrix is given to us. And notice it's got some letters in here, some variables. They want us to compare it to B. How would we make A and B to be equal matrices? Do we have to do anything to the first entry? No, 7 and 7, 9 and 9, 0 and 0, -1 and -1. So we're in good shape so far. But what do we have to do with these folks? What do I have to do with X? It's got to be the same as this one, right? So that's kind of the easiest one. X has to be equal to 0. Boom, I solved something real quick. What about this one? What does it have to be equal to? It has to equal 11. So y plus 1 has to equal 11 for these to be equal. -1 from both sides. Y has to be 10. Solve something there. So this is something we might have to do. These two are equal. What are those values? Okay. So far, so good? Okay. So remember these concepts, though, because sometimes, again, they'll come up later. And you just want to remember equal matrices, same size, exactly the same entries. And there's some in the homework like this. They'll give you two matrices and a couple with letters. You just got to solve it, right? Some will be easy. X equals 0. That was nothing more to do. Y plus 1 was a little bit complicated. We actually had to do some algebra, but we're okay. Okay. Some special vocabulary here. What might be a good name to call this kind of matrix? 1 by 5, or 1 by 6, or 1 by 4, 1 by 3. Square? A square has same, you're good. Save that for a little bit later. So a square shape, we'll have a square matrix, but this would be what kind of a matrix? It's a row. So that's the other thing is, yeah, columns and rows, I tend to mix up myself. This is a row matrix because it's just a one row. If it had two rows, then it's just a matrix, right? So this is a special matrix. A row matrix is one that has only one row. Okay. So with that in mind, keep your answer in mind. What do we call this one? Column matrix. Yeah. So it's only got one column. Okay. It can have as many rows as it wants, but it's only going to have one column. So if they say they've got a column matrix, you know it's just straight down. Okay. And now, third one. What if it's a 3x3, a 4x4, a 6x6? That's a square matrix. Okay. Oops. Oh, forgot to hit the button. Square matrix. So these are just 3 vocabulary words. If you see them, you've got to be able to visualize what they're talking about. Okay. And again, the biggest problems I have is between rows and columns because they get mixed up. Rows are down, and even when you think about them, rows are going down, columns are going over. But look at the column matrix. I don't know. Anyway, I have so far so good. It's vocabulary. Okay, now we get to the math part. Like all that was math too, but how do we add and subtract matrices? Now, if we're going to add 2 matrices together, would it make sense, going back to if they're equal, wouldn't it make sense that they would need to be the same shape? So if they're not the same shape, how are we going to, what does it mean to add 2 matrices? So we're going to just, and once we figure out addition, subtraction should be just like it, except we're subtracting instead of adding. So here's our concept. First of all, they have to be the same shape, same dimensions, just like being equal. Because all we're going to do with the matrix when we add it is we're going to add them term by term. First column, first thing, with the first column first, we add them. So entry by entry. So all the entries have to sort of line up. That's all the addition is going to be. Same thing with subtraction. So to add them together, we just entry by entry. Okay, so the same entry gets added to the same entry of the other one, so they have to be the same shape. So if I have a 3x4 and a 4x3, can I add them? No, they're not the same shape. The numbers are the same, but rows and columns won't match up. So they got to be the same. So here's an example. We're going to do another example, but it's just they have to be the same shape. You take row 1, column 1, add it to row 1, column 1, and you get the new answer. Okay, so entry by entry, you're just adding them. Again, you see it's not complicated, it's not hard, but it's tedious and technical. You gotta stay focused. It's so easy to get off on a row, especially as they get larger. And this was one of my we have technology now, but I remember learning this back in the 80s, and we didn't have the technology. We had calculators that only had one line. They didn't have graphing calculators even. Hard stuff, right? How can we live without graphing calculators and be a math major? Well, we had to do matrices on paper, and again, it was never in my mistakes were I added 2 plus 3 and I got 6 because in my head I multiplied instead of adding, and then I kept going. Finding that error was like the hardest. It sometimes take me an hour just to find a little error like that. Okay, so nothing is mathematically hard, challenging, but it's the focus and organizing thing. Keep your work organized. That's what as you see me, I'm kind of all over the place. So it's going to help you if you can organize your work as you go, because you might need to go back and find some arithmetic errors. Okay, let's just do one. So here we're going basically the same matrices. One says to add, one says to subtract. So what am I going to get for the first part over here? Right? 2 plus 9. Here I'm going to get -3 plus -5. So you could, this is one sort of good way is copying them over, seeing everything you're going to do, and then rewrite it. 1 plus 0, 0 plus 13, -1 plus -1, and 3 plus 3. You add those individually, and you'll get your new matrix. So 2 plus 9 is 11, -3 and -5 is -8. But you see, if you don't write them down, part of the problem is you may mentally drop, especially with that -3 minus 5 plus -5, you might have said, oh, that's -2. You might have subtracted them somehow, or, easy to do those kind of things. But it's hard to find those errors unless you maybe do something like this. And if you write them out. So this is just a strategy. And that's one of the things we need with matrices is the math is not hard. You look at, oh, I can remember that. But 10 minutes after class, oh, what was he talking about? Until we do it a few times. And even then, some strategies are helpful. -1 and -1, actually, you add them together, you get -2. So not difficult. I'll show you by the end. I want to keep moving. So the calculator will do this for us as well. But we also want to be able to do with at least the smaller ones something. If we're subtracting, this is a little bit even harder. Again, if we don't write it out, because this one we might, it's easy to make these mental errors. -3 minus -5, which is going to be a +5, and that does give us 2, right? -3 and +5 gives us 2. But again, it's with subtraction, it's a little bit easier to get off by a negative. Maybe you put this as 13 instead of -13. But notice we're just subtracting each entry from each other entry. Okay, so write them out. Might be helpful if you're good at it and you're able to keep yourself. But watch yourself. See how you're doing. That's what I do. Is when I make mistakes, I go, why did I make that mistake? It's going too fast, and I'm the guy who needs to write them out like this. Some of you won't need to. You're just sharp like this, and you get your facts, all things. But I mix my addition, subtraction, multiplication, division. I mix them all up. So again, we get 2 minus 9 is -7. But you can see how critical this could be if you put a +7, you're sort of right, but you're off, right? +7 and -7 are on the opposite side. And so if we're using this for a business decision and we give our boss +7 instead of -7, that could have very different consequences. Okay, so again, a lot of this is just strategies for knowing what kind of errors we make individually and adapting to that. Some people will make more errors by copying than trying to do it mentally. So you need it. So I don't want to tell you have to do it this way, because I might be wrong for you. If you do it my way, it might work for me, but it has to work for you. So find the method. Again, something very simple is just entry by entry, either adding or subtracting. So far, we good? All right. We're almost there. We got multiplication. Now, there's going to be two types of multiplication. Wednesday, we do something called the dot product. It's a different type, and that one's kind of, well, we'll worry about it later, but it's a type of multiplication. This is just called scalar multiplication, and just think of it, scalar comes from the word sizing something up, so make something larger or smaller. So what we're going to do is we're just multiplying by a number. So if I multiply by 2, I'm scaling everything, I'm doubling everything. Multiply by 3, I'm tripling everything, right? Multiply by 3.25, whatever that is, yeah. I could also multiply by a fraction to scale it down, right? 0.5 would cut everything in half. So that's what the word scalar comes from. Again, I remember learning this and the professor was throwing that word around. I go, what is a scalar? And it took me years to figure that one out myself. But it's scaling it up or down. So it's going to multiply everything. So here's an example. We've got 6, and all we're going to do is take each entry times 6. So 5 halves times 6. 6 times -3. 6 times 1. 6 times -1. 6 times 0. 6 times 5/6. That's all a scalar does. It multiplies every item, every entry in the, so just think of it as the major, a large distributive property. That's all we're doing. Distribute that scalar, that 6, to everything. So we've just increased the size of everything by 6. We come over here, we could check it. Yeah, 6 times 5 halves. 6 divided by 2 is 3. 3 times 5 is 15. So again, you might want to, this doesn't have to be done necessarily. Like on an exam, it says show your work. You don't have to show this if you can do it in your head, but it might be helpful. I might need to do that because I would probably make some mental errors in transferring that over. Again, know yourself. Uh, and even I might say the right thing, but anyway. So that's just I have to show you what we're doing. We're just multiplying everything by 6. So whatever that number is, multiply. Scalar multiplication, easy. Dot product multiplication, not so easy. We'll deal with that Wednesday. Okay. So get the. That's why it's good to, if you can, after this, go ahead and look through the homework. This is going to be straightforward. Wednesdays is not so straightforward. And I'll even have a challenge explaining it because of this rows and columns thing that goes on. Okay. Scalar multiplication. I want to highlight this. Is this, what are we multiplying by here? -1. Okay, so that negative on the outside, it just distributes. So multiply everything by -1. Quick way of thinking of it, everyone's going to change sign. So any positive numbers become negative, any negative numbers become positive. So that one you might not want to actually, I'll write it out just because everyone else who's looking, we're really just multiplying by -1. -1 times -2, -1 times 0, -1 times 6, -1 times 10, and -1 times -6. Oh, I could have left that. And we'll see that the signs just all changed, right? So that might be a quick way. This one is one I would not write down. I would write the answer down because I said, okay, just change all the signs. If I write all the other stuff, I'll probably make a mistake in copying. So know where your challenges are and how to go forward. And so it's a way we could think of, if we have to subtract 2 matrices, it's just adding the opposite. So you make the second one negative, do a scalar multiplication by 1, and just add them. So it's just a quick way saying that, we don't really need subtraction. We could just add the opposite. We could do that with numbers as well. Okay. Also, there's something called a zero matrix. What do you think that would be? A matrix with all zeros in it. It seems reasonable, right? So somebody, again, in math, we just have to define everything because we might need to use this. And so we might want to say, oh, use the zero matrix. What do you think happens if you add a zero matrix to something? Well, what's 2 plus 0? Still 2. It's not going to change anything. So it's kind of like an identity of it. So if we add, but what if you think if we multiply by a scalar of 0, right? Everything will become this 0. Okay. But they indicate it with an O. So you may see this in the homework when they have matrix A, B, C, and O. O is not some unknown matrix. It's the zero matrix. Okay. Maybe for origin. Origin, everything starts at 0. Almost there. All we got to do is transpose. And this, again, is one of my favorites because I sort of do it naturally. Oh, I forgot. Before we go there, we're going to talk about properties. Okay. The cool part is matrices, arithmetic with matrices work just like arithmetic with numbers, at least with the addition, subtraction, multiplication, scalar multiplication. Now, again, with matrices, we have a second type of multiplication, and it doesn't fit these rules. So that's why we kind of go through it. First of all, if these are 3 matrices, we can use the associative property. If we're going to add them all together, we can group them differently and still get the same answer. Okay, if we can add 3 matrices together, we can add the second 2 and then the first one, or we could add the first 2 and then the third one. We'll get the same answer. So you can choose how you want to do that. That's called the associative law. We can also do, with matrix addition at least, it's commutative. means you can change the order and you'll still get the same answer. A plus B is B plus A. Okay. So again, a lot of these will just, because things will come up and can I really do this? Yes, you can. Okay. We're not going to go into proofs. That's if you're a math major, those are the types of things they have you do. Here's the one I was talking about. If you add the zero matrix to anything, you get back the same matrix. So 2 plus 0 is 2, right? It stays the same. A plus 0 is still A. We haven't changed it. And they call that the additive identity law. Sometimes their names sound more pretentious than what's actually going on, right? It just seems simple. If I've got a scalar time, if I got adding two matrices and I'm going to multiply by a scalar, I can use a distributive law. I could multiply by the scalar first and then add them, or I could add them and then multiply that by the scalar. Get the same thing. There's also another way. If I have a matrix and I'm multiplying by two scalars that are being added, I can either distribute or I could add the scalars together first. I think I would add the scalars because that seems, but these two both work, and these are distributive laws. So scalar multiplication distributes over matrix addition. If I multiply by 1, what's going to happen? Nothing. So that's 1 is still an identity element. So it's a scalar unit. I don't know where they get that. I multiply a matrix by 0, I get the 0 matrix, kind of, because that's how multiplication works. Multiply by 0, everything becomes 0. Multiply by 1, nothing changes. So these are all the same type of properties. Again, what we're going to see is that some other operations with matrices don't follow these rules. These are ones we're used to applying and using in our number, just single number arithmetic. Matrices work with these, what we've been talking about, but we'll get to some, especially when we get to that thing called the dot product, is a type of multiplication. It doesn't follow that rule. This is the last concept, transpose. What do you think a transpose is? Transposing, you switch two numbers, you switch the order. So we're going to take the, better read it. So we're taking a m by n, so a 3 by 4, and we're going to make it into a 4 by 3. So the rows become columns, the columns become rows. Sometimes harder to explain than to do. We'll see how this works. We use this little letter with a little t up here to mean transpose. So if this is our matrix A, this over here would be the transpose of A. And notice the column, the first column becomes the first row, the second column becomes the second row. So it just kind of, I don't know, goes from vertical to horizontal and then slides into place. So each item, entry by entry, is also, you could just switch the indices and you get it right too. But just think that first column is going to become the first row. So let's think how we would do this one, right? First, it's a 3 by 4. So what size column are we going to, or what size matrix are we going to have? A 4 by 3. So that's kind of helping us, right? We've got a 3 by 4, so we're going to have 4 rows and 3 columns. So 4 rows, what's going to happen? We're going to take this first column and turn it into a row. Oh, that's not so hard. We're going to take the second column and turn it into the second row. And see, there's really no mathematics that we're doing, but we're just copying over rows to columns. And then 1, 0, 2, and 0, 5, negative 2. And that's it. That's a transpose. Not so hard. So it's really just copying over, but again, make sure I did it all right. So easy to make a little error in one of the, getting something out of place if you're not careful. If you're thinking, oh, this is easy, let me, and then you go on to the hard part. But the problem is, if you get to the hard part and you've already made a mistake, and then you think your mistake is in the hard part, so you spend an hour looking at that, and it wasn't. It was in the easy part that you glossed over. And I'm talking about myself. I spent years of doing this, and I love matrices. This also leads us to something called linear algebra. It was one of my favorite things, but it was also one of the more challenging ones. Okay. But it's sort of, it mixes algebra and in a nice way, but just be careful. So that's my message today: is the stuff we're doing is not difficult today, but it forms the basis of everything we're going to do. And if we make a concentration error, then when we get to the stuff that is going to be more difficult, we're starting off with something that's not correct, right? And then so we're going to not get the right answer, and then we're going to think, oh, it must be in this hard part that I did, but it isn't. It was in the very beginning when you just added the two matrices and then you started working with it or something. Okay. And this is the last one. These are the properties of transposes. Again, we could just apply them. So if we're taking two matrices, we're going to add them together and then transpose. We could transpose them individually and add them. We'll get the same answer. That's all it means. So transposing sort of distributes over addition. If we're doing with a scalar and a matrix, transposing, basically we could do it in either order. We could take the transpose first and then the scalar, or we can multiply by the scalar and then do the transpose. So these ones are helpful because you might say, hey, it might be easier to multiply first and then take the transpose, because maybe when I transpose, something happens or whatever, you know. And a transpose of a transpose gets us back to where we start, right? Because we took, let's see if I do this right. We took the columns, turned them into rows, and then if we do it again, we get right back to where we started. Does that make kind of sense? And I keep clicking to go to the next slide, but there are no more slides. So that's the lesson for today. But let me give you, see how much time do we got? I only need about 5 minutes. We have more than that. So then we have, and then I do have office hours if anyone wants to stay and talk and chat about anything. I'd be happy to talk about the exams, but again, I'm just holding on to them because we're not going to do them again, and I want to make it fair to you as well, so that they don't get out there. I will make a new exam for the makeups. So that's the other part. They will be similar. Not that I'm going to make it harder or anything, but I've got to make it similar. But at the same time, um, we'll do that. So let me get out of here. And I just want to show you um, a few techniques with the TI-84 calculator. Other ones, Casio has matrix operations as well. But where it's helpful is, let's see, can I make this bigger? Oh, good. First of all, I just kind of want to show you um, matrix is above the x to the -1, so it says matrix, it's blue. So you go second, not test, second matrix. Oh, second matrix. There we go. I'm going to take these. Well, let me do. So here's what it does. You've got names of matrices. So if you've got a matrix set up, you can, if I were to hit enter right now, it actually takes that matrix and sort of puts it in a place. I could graph this matrix. I don't know what it would look like in a graph, but if I was in this field, second, I wish they'd make it like a first one. When I do that, I could now take A, since I got B set up, I could go matrix B. Am I going to be able to add these? Can I add a 2 by 4 with a 2 by 3? No, but I'm going to try. See if the calculator can. Nope, the calculator can't either. So part of this is it will tell you, the calculator will tell you what you can and can't do. And so that's that part. So, but you could actually do the addition, because you could see as we get larger matrices, it just gets so tedious if you can enter them in, and we're going to use them. And that's what we're going to be doing before long, is there's a lot of different things we can do with the matrix. Let me quit. There we go. The other thing is you can, so there's all these math. We'll show you how these things work. We'll also show you how to do them by hand with smaller matrices. But if you have a larger matrix, we definitely want you to use these tools. But the edit, that's where you set up a matrix. So let me go for like C. So no, there's nothing here. So to set up a matrix, I tell it rows by columns. Well, I can't remember which one. So let's see, if I do a 2 by 3, is that 2 rows and 3 columns? Oh, see, it tells you right away, rows and columns. So it works just like it's supposed to work. So if you forget, you could just go, okay, what's a 2 by 3? Oh, it's 2 by 3. 2 rows, 3 columns, okay? And then you come in here and you can enter your numbers and you could just hit enter and it goes to the next one, you know. So you just, whatever you're doing. Um, and I'm just entering some random numbers. So that could be your matrix, right? And this is a 2 by 3. And if we go back, let's see. Oh, to go back again, you always have to kind of go second matrix. And now I have to. Can I add B and C together? Yeah, because they're the same shape. So that's another nice thing you can see. Let's see what B is. I don't, oops. You can actually put a matrix inside of a matrix too. There's some weird things that can happen. Let me go here. Let's just do it this way. So if I go from here, I could, yes, I could take B plus matrix C. I don't know what's in B. We'll take a look. I might have made it the zero matrix. No, it's got something. But what it did is it, entry by entry, it added them together. If I want to see what's in B, I have to go to matrix, I have to go over to edit, and then I go down to B. Oh, a bunch of random numbers that I put in earlier. So, but you see, I can use it for adding. I could use it for subtracting. So I just want you to, as you start doing things, go ahead and start using this so you get comfortable with your graphing or your matrix tool. Okay, because what we're going to do Wednesday get a little more complicated, but this thing will do it for you, so you can kind of always check your answers. And especially as we get to bigger matrices, we got to use the technology because it's just so tedious. I mean, I remember I had 3 pages of work, and then when you make a little error on one of the entries, you had to go back. But this one, um, we'll talk about the individual um, operations that we do on them, but we're going to really heavily rely on this to do it for us like that. Just give us the answer. So there's some features in here that will work well. So start practicing with that. And again, today's just sort of the foundational build day. We'll be spending 2 days, 2 full weeks, sorry, 2 weeks on matrices. So we'll pick up some more complicated stuff called a dot product, a different type of multiplication that does different things. Gets into vectors. There's a lot of interesting mathematics we can do with these, um, and for making decisions and stuff. And then we'll learn to manipulate them. We'll have a system of equations as a matrix, and we'll solve those and get our values that we need. And again, we can use these calculating tools because they don't have an XYZ in there anymore. Those are implied, but the matrix will have the numbers. It can do all the calculations for us, give us our answer like that, instead of going through 3 or 4 sheets worth of calculations. Okay, so good on that. Awesome. And again, I thank all of you for coming regularly, doing what you can, staying on track. And again, that's because that's best for you. If you can do a little bit each week, a little bit each day, learning sets in and you'll retain it much better. All right. So that's all I got for today. Have a great Monday. You too.